Welcome to chapter 3. So in chapter 3, we'll be looking at equilibrium of a particle, the free body diagram, and the coplanar forces. At the end of the day, you should be able to draw the free body diagram and apply the equation of equilibrium to solve the 2D problem. So from your textbook, I'm looking at 3.1, condition for the equilibrium of a particle. So what does it mean by being equilibrium? It means it is rest. So the summation of forces, you can have force in your x-axis, force in a y-axis, but the summation of all these forces will be equal to 0. So that is the meaning of it. So if you see here, the resultant force acting on the particle equal to 0. So resultant force. So if you have a force on the x-axis, let's say 10, and then in the y-axis, let's say it's 10, in the z-axis it's 10, there will be like if you sum up of all these forces, maybe I should just draw and show it to you. Let me just draw here. Okay, so let's say I'm standing in the middle, so this is me, and I have student A pulling me 10 Newton here and student B pulling me 10 Newton to the left. So what happens to me? I will not move because Fx in the positive direction is 10 and Fx in the negative direction is 10. So when you write summation of forces, so we have 10 minus 10. Why minus? Because one is in the negative direction. So that's what happens. So this becomes 0. Okay, so now let me just go back to the lecture. So that would be chapter 3.1. Another way of having summation of forces 0 is when your acceleration is actually 0. So particularly, consequently, the particle actually moves in a constant velocity, or it remains in rest. So that is also 0. Equilibrium. Okay. Wrongly. Wait, let me just go back to the part of the lecture. Okay, I've wrongly highlighted all this. Double highlighting. Okay, just leave it there lah. We undo and then we undo again. Okay, that's leaving you with 3.2. Okay, let's look at 3.2. So when you say free body diagram, that is the simplest most of the diagram that shows all the forces at the surrounding to the body. So that's called the FBD, free body diagram. So we're going to analyze on few, which is one is the spring. So spring gives F equals to Ks. K is the spring constant, S is the length, the extension. So how to represent this? You just need to draw a line to the direction of the spring's force. Next would be cables and pulleys. So we have, can you see, T and T in the length along the cable itself. Okay, and then we have the smooth contact. So if you have smooth contact, you have N. Do not forget N is the normal force, and T was existing in this diagram. So weight is always pointing downward. That is for the smooth contact. Okay, so that's how you draw your free body diagram. So let's move to the example. Let's see what does the next page tells. Okay, let's look at this diagram here. We have a 5 kilogram plate suspended by 2 straps. Can you see A and B? And then we have weight, because they have mentioned 5 kilogram. So how do you draw the free body diagram? We are not in arts class. So simple thing, just draw a circle, draw a cable here, TA and TB, and the weight down. 5 times 9.81. That's it. That would do. That's drawing the free body diagram. So let's look at one of the question, for better understanding. So we have this situation here. Now remember, a free body diagram, when you draw a free body diagram, you have to isolate. You may have 2-3 objects jumbled up together, but you cannot draw everything together. Like example, let's look at these. We have a mass of 6 kilogram supported Draw a free body diagram of the sphere. So what do you have here? Draw a free body diagram of the sphere. So this sphere, they're talking about this sphere here. So you draw a sphere, just a round thing. There is a force EC up there. Can you see CE up there? And there's contact force NA and NB at the side, and the weight down. That's it. And then cot CE. Where is CE? Okay, this is CE. So what do you have? You have a force upward. This is cot CE, correct? Okay. Along cot CE, you have got one force, which is CE, and then another one is EC. Yeah, there's a force EC up there. So that's cot CE. We have done. And then the last one, the knot. Yeah, they're talking about the knot C. So where's the knot C? It's here. So you draw the knot C here. Okay. And then what else you have? You have got force CE here. Let's look at the knot. We have the spring here, and then we have 60 degrees BC here. So just redraw. Can you see? BC. We have the spring that's acting on the knot, just a straight line, and then we have the CE. So we have drawn the 3 free body diagram for this diagram. So this diagram can be very complicated. There are a lot of things that you can draw for this diagram, but what you do when you draw free body diagram, you have to pick one thing at a time. If the ball, the sphere, then it's the sphere. If the spring, it's the spring. Or probably this joint B here, then it's the joint B. So if you draw joint B, how is it going to be the pulley? The pulley is going to have just 2 forces, something like that. That's the pulley. That's one here, one here. That's it, finish. Yeah. So with that, I've ended the first part of chapter 3 and explained to you on 3.1. I'll be going into coplanar forces in the next lecture. See you.